Hi everyone, today's July 31st, 2023, and I'm in the middle of a field getting ready, waiting for this stuff the dew to burn off. Got a little rain on it last week, but it smells really sweet still. So I'm baling it and I'm gonna feed it. But this next video that I'm going to share with you is a correction about the other video prior to this one. And I'm hoping to make it a little bit fun. So it's got something to do with tractor pulling. It's a two-wheel drive truck that I had built, started building 20 years ago, and finished it in 2007. But there's some angles that I'm sharing that is going to be used. It's the formula that I have trying to show a correction. And this formula you can use a lot in farming, building gates, building your auger systems or whatever. You can just try it out and see how it works out. And it's been very useful for me. Okay, what I've got here, this is the chassis off of the 48 Ford Arc Force. It's handmade. It's square tubing, ladder bar frame that I had made. And it's got a Rockwell axle in it that has been modified and narrowed. And measurements from center of axle to back of the stabilizer plate. This plate, you have to follow rules. This plate has to be, I think it's 4 by 5 inches or something like that. 5. I ended up making mine 5 by 5, and this has to be within so many inches of the back of the tire, and I think that's about where it's at. It's right there. Center of this is probably 2 inches when the tire comes around. And if this stabilizer bar is right behind the wheel, it can't be more than 6 inches off the ground. And if it's not within tread of the wheel, it can't, the maximum is 10. Now I've got this up on jack stands so the tires could come off, and I think I set mine at 8 because it's inside of wheel tread. But now this is what they don't tell you. Well, they tell you it has to be 2 inches behind the wheel. So to get this math, what I'm talking about, let's say I'm 20. We'll say 28 inches, because this is going to dig down into the ground quite a bit. But we'll go 28 inches from there and 8 inches up. And then we're going to find that angle. And then that angle is going to determine how far off the ground the nose is going to be. And you don't want it that tall. But you're going to lose a lot of traction once that wheelie bar or this stabilizer bar hits the ground. It starts lifting the wheels off the ground, and you lose a lot of downward force. So we always like going to the rules. Take them as far as you can, and that's the reason their safety is there to keep us safe, but yet we still want to be competitive. Okay, what I have here is a draft of what I just showed you on the back of the chassis of the pull truck. And what I've got here is length, which we're going to call run. And then I've got set. Now these are different. This is how I use it. Your math teacher may call this opposite and this adjacent. But this is how I stuck to me when I learned it. So I call this set, and I call this run, and I call this travel. And the rules ask us to not to put the stabilizer bar, if it's in tread of the tire, it has to be a minimum or maximum of 6 inches high. And if it's not in line with tread and it is like where the frame is here, maximum can be 10 inches, and mine is 8. And there's times I kind of wish I had a little bit more. I may change that. And so what I've done here is, you don't go by center of tire. You're going to go 8 inches off the ground, and that's your set. And then center of axle down to the ground, or the bottom of the tire over, is 29 inches. And this plate has to be exactly 2 inches behind the back of this tire here. The furthest most point can't be more than 2 inches past that. So what I've got here is the angle. We want to find out what the angle is. And I kind of shuffled around back and forth to find out what height I wanted that truck to go when I first started it. And I'm just going to say 59 inches high. Now, you realize that when this length is from here to the nose, and you go up 5 feet, it's going to shorten right here because of that angle coming up. We'll go over that formula next as soon as I explain this. So what I ended up doing is taking 8 inches. I used decimals, used the zeros, and I took 8 inches divided by 29 inches, got an answer, equals answer, then push second function, then push tangent, and that's the angle that I got at 29 inches of run and 8 inches of set. Now reverse that. Now we're going to go from center of axle to nose, which is 15 feet. That's what the rules are for at NTPA, at least it was in 2009. So you're going to take the 15 foot plus the 29 inches, and I get 209 inches. So I'm going to take at 59 inches is what I want it to be. I don't want to go any higher than, 58 to 60 inches. That's 5 feet. That's up there. So you take set first, 59 inches divided by 209 inches, and you get an answer, and then you push second function, then you push tangent, and I got 15.764, and that's close to the 15.422. So that's how I figured that out. So it's set divided by run, and you get an answer, and you push equals, then you push second function, then you push tangent, and that's how you're going to get your angle, taking the set and the run. Now, if you're going to build a rafter, you're going to be short right here. So you've got to figure out a different formula for this up here. We just figured out angle. Now, if you want to figure out travel length, that's a different reason why you're going to do that. So what you do there is you take set square plus 209 inches squared equals, got your answer. Then you push this one, and you get 217 inches, 0.168, and that's what's going to push it out a little bit further so it comes out even with that run. If you're going to build a rafter, or if you're going to put your grain auger up on the grain bin, because it's got to go up to the center of the bin. So that's what I ended up doing, and now I want to go over it with the calculator and make sure you understand. Okay, to find the angle, wanting to use a formula where you're going to use the calculator. This is my phone. You flip it sideways and it does this. Always want to make sure everything's cleared real good in case there's one of the buttons are still holding on to the symbol. But anyways, to find the angle of the truck when it's up in the air at 5 feet, so we're going to say 59 inches. So you got to do in decimal 59.000. Got to use the zeros. And you want to divide that. This is to find angles. And then take the run. The run is 209 inches equals second function. This one over here. The 2 and ND, second function. And then you go to tangent. TAN says -1, tangent. And we get 15 degrees, 0.764. Roughly, I'm guessing at 15.5. So from the back of the stabilizer bar up, it's 15.5 degrees. And that's the formula. Set divided by run equals, then push second function, then push tangent, and you get that. Now, if you're wanting to find the travel, this length right here, because maybe you're building a gate and you want to put a cable on it, or you're trying to figure out how long of a elevator or auger you need to go into a bin, or maybe you're building rafters and you want to come out even up here from the bottom up here, you want to be square because the pull truck's going to lose some distance. So there's another formula for that, and it will be right here. It is set squared plus run squared equals, you get your answer. Then you push 2 square root, and then you get your answer. 217 inches of travel. So if we want to be square with the bottom to the top, you have to add to it, because you're going to lose some distance there if you go by this measurement here. If you go by this measurement here and roll it up, you're going to lose distance. So you have to add to it. That way when it comes up, it's even with the bottom. So I hope this has been helpful. And it's always worked for me. And it's one of the pipe fitter things. And a building, anything, windows, anything to do with frames. It's a good formula. 2 of them. Travel length and angles.